Well, happy Monday, class, or whenever you're listening to this. This week, instead of surging ahead and doing something else in math, we're going to review what we did last week because it's very important, and I think the class was making progress in understanding. And if you did well last week, then this will just really make it easy for you. So what we're going to be doing is we have to remember what mental strategies are. First of all, mental strategy does not mean you do it all in your head. There is writing that goes on, but it helps you to find products for multiplication that otherwise you would be unable to solve. When you see the answers, you think, wow, that's a high number, but you got to that number by using sort of mental strategies. So try to put the calculator aside, maybe use it as a checking tool. Remember we said if you need a multiplication grid, but I do think you have to start to work off the multiplication grid. And let's get started. So one of the easiest things to do is to use a friendly number. And the best friendly numbers people would think is probably 10, right? So 8 times 10 times 4. I can use a commutative property, which means that I could switch the numbers around and it doesn't affect the product. So I could say that I'm going to have 8 times 4, and then it's going to be 10. So if I know my multiplication tables, then after that, multiplying by 10 is easy, right? So 8 times 4, waiting for it. Okay, it's 32. I hope that's what you said. And then it's multiplied by 10. Now, almost everyone I talked to last week knew that for multiplying by 10, you're just adding a 0. So 320, right? So just like I said a minute ago, that you come up with a product that's pretty high, and you're pretty impressive, but all you did is use those mental strategies that you're aware of. Okay. Now 10 is not the only friendly number. 100's a pretty friendly number too. So when you look at the question, you have to find where the 100 is. And basically I know it's right here. So it's that and that, right? The 50 and the 2. Because I know if I multiply them, I get 100. So again, if to make it easier, I could move the numbers around so that to use a commutative property, right, to keep the numbers together. Now, I know that 50 times 2 is 100, and then I can multiply it by 7. Now, 100 is a friendly number because instead of just adding one number or 1 0, you're going to add 2 zeros. So 7 times 100 is 700. Okay, so and remember, you can always pause this video or re-listen to bits and pieces of it if you think I'm going too fast or if you want to hear it again. Let's move on to the next one. Okay. Now, the other thing we could do is break up a number. And we're going to break up the 60, right? And in this case, breaking up the number really helps because if you don't break up the number, it probably doesn't work out as well, okay? So if we break up the 60, I'm going to get 10, and then I would break up the 60 into 10 times 6, and then times 3. So the 60 is 10, and then it's 6, those two numbers, okay? Now, some of you might be saying, well, now there's 4 numbers, but actually 4 numbers makes it easier to multiply, right? So 10 times 10, we know is 100. And then 6 times 3 is 18. Okay, now we know 100 is a friendly number. It's just a matter of adding 2 zeros. So 18, and we put on the 2 zeros. So that the product of 10 times 60 times 3 is 1,800. Okay. Something else that came up in the work last week is the fact that you should know your 25 times tables. And I know that sounds ridiculous, but it's not that hard. And you can also think of 25 cents. Like how much money do you have if you have 2 quarters, right? You have 50 cents. If you have 3 quarters, and then once you have 4 quarters, then you have $1. But 25 times tables actually makes things easy too, right? So if we start at the top, okay, so 1 times 25 is 25. 2 times 25 is 50. 3 times 25 is 75. And then, like I said, if you have 4 quarters, you have $1, or in this case, it's 100, right? then you can go a little bit over, but it repeats. So it's 25, 50, 75, 100. Then it goes 125. Okay. Then if you do 6 times 25, it's 150. So it's sort of, these numbers here, they all kind of repeat until you get to the next one. Now, something else you would notice is that every fourth number, so 4 times 25, right, is, ignore that. That's my nephew. Okay, so 4 times 25 is 100, and then 8 times 25 is 200. So every fourth number is like 100, 200. So then when you do 12 times 25, you get 300. Okay, and then the next one would be 16, right? So 16 times 25 would be 400. So 25 times tables are pretty useful. Now, for this strategy here, we'll break it up. Okay, so we'll break up this number here, 125, right? So I could say that it's 2, right? And this one, well, it would break up to 25 times 5, right? And that's from that part there. And then it's times 8. Okay, so we broke up the large number just like we did in the previous question. Then I could say, oh, I could use my commutative property again, because if I move numbers around, I see a friendly number. So it's 2 times 5. Okay, these two numbers, because they'll make 10, right? And times 25 and times 8. Okay, so this would equal 10. And this here, okay, now that creates a little bit of a problem because, well, 8 times 25, well, actually, it doesn't create a problem. But if you said, well, maybe I use a calculator for that, but actually, we solved that question because we did 25 times tables, and that 25 times 8 is 200. Okay. Now, there's lots of zeros here, but remember, any number that's multiplied by 10 is just a matter of adding a 0 to it, so it's 2,000. Okay. Now, if I wanted to, okay, this is a good time to use a calculator, right? I could do a check, right? So I could go back to the original question. I could say 2 times 125 times 8. So if you're going to use a calculator effectively, it is good for checking to make sure you did those mental strategies correctly. But if you're just going to use a calculator right away because I'm not around to see you, then I would say that you're not really applying your mental strategies. Okay. So the last one is using one type of question to solve others, right? So you should know by now that 10 times 8 is 80, right? But sometimes another friendly number is 20. So 20 times 8, right? So 20 times 8 is always double this product, right? So it would be 160, okay? Now, this question here is probably more helpful than 10 times 8 to help you solve what's left here, right? So we want to find a value of n, right? So we can do like we know that 20 times 8 is 160. Well, that means that really there's 2 left over. So I could even rewrite that. I could say 20 times 8 equals 160, right? And that means that there's just 8 left over because with these two numbers, right, we want to get to 168, right? So that's 1 times 8. So basically, these two numbers are you use addition, and then these two numbers you can use addition, and then we know that it's 21, right? Yeah. So here we'll make this 21, so that 21 times 8 is 168. Okay. I'll use my erase tool here. 21 times 8. Okay, and when you break up a multiplication question into 2 parts, it's called distributive property, right? Let's use that for one more. So again, we already know that 20 times 8. Okay, 20 times 8 is 160, right? Now, how much is left from 176 to 160 if you subtract the two? Okay, I hope you said 16. Right, so 16 is left, because if you add these two numbers, you get 176, right? So something times 8 gives you 16, right? That's a lower number, so hopefully you figured out that it's 2, right? So 2 times 8 is 16. So if you add these two numbers together, then you know that that P is equal to 22. And there you go. So on the lesson, on the page, on the hub, you'll find basically the sheet that has more questions, but hopefully with the practice, you should get through it okay. Okay, so thank you for listening. And if you have any questions, we'll go on a live lesson probably on Thursday. And I hope you have a good week. And I'm so proud of you all for sticking with online learning as we get into June. Okay, and I hope, and stick with it. We only have a few more weeks. Bye.